Let's start with the first question. As you can see, first question, the unit of reduction factor of tangent galvanometer, because we know that the tangent galvanometer will measure the ampere, the current. So the first question will have the answer to as an ampere. Straightforward answer, because Gauss and radian cannot be the answer. Radian cannot be the answer. None of these cannot be. Gauss is for the electric phase and all those things. Ampere, first question. Second question, the surface tension has the same dimension as that of coefficient of viscosity. Alright, let's see. First of all, you need to know what is the unit of surface tension. Instead of finding the dimension, better is to go for the units. Surface tension can be taken as force per unit distance, and if I take force per unit distance or length, that means it's Newton per meter. And let's see which one has same dimension as this one. Coefficient of viscosity, cancel. Impulse is basically nothing but force into time, which is again not similar to this one. Momentum is mass into velocity, not similar. Spring constant is nothing but force is equal to your spring constant, force upon displacement. So this matches with this one. So spring constant has the same dimension of the surface tension. Let's move on to the third question. The particle starting from the rest falls from a certain height, assuming that the value of acceleration due to gravity remains same throughout motion. Its displacement in 3 successive half seconds intervals are s1, s2, s3. Then, so basically it says that the particle is falling. So in the first half second, next half second, and the next half second. So every time the distance, we need to calculate the distance now, because we know that the acceleration is happening. That means each time the distance should keep on increasing. Now we should know that your bikinematic equation is equal to ut plus half at square. In this case, u is 0, acceleration is a constant, okay, so that means s is equal to half at square, which is nothing but displacement is directly proportional to t square. We're considering acceleration as a constant value, so that means displacement is directly proportional to your t square. That means now let's start with s1, the distance s1 for t1 second, s2 for t2, and so on and so forth. So if we take the ratios, s2 with s3, that means we should get t1 square is to t2 square plus t3 square, and so on. So first half second, that means half, then 1 second, and then 3/2 second. That means take square of each of them, you get 1/4 is to 1 is to 9/4, which is nothing but 1 is to 4 is to 9. So that's the answer. So you take, and then after 1, 4, 9, that means every time this is the time, that is the distance that is taken. Now what you do is, because every time you're increasing the distance, right? That means in first half second the distance is, let's say, 1 meter. In next half second the distance will be 1 plus 4, which is 5. In the next half second the distance will be, because this is 9 plus 9, yeah, correct. So in the next second you will get, no, cancel it out, not this one. In the first second you will have 1, in the next you have, because distances are increasing, so the next second you will have 4 minus 1. In the next second you will have 9 minus 4, which is 1 is to 3 is to 5, which is right. Next one, let's see. A particle is projected from the ground with an initial velocity of 10 meter per second at an angle of 60 degree over the horizontal, from what height should another particle be projected horizontally? Alright, you can read the question. Let us directly move on to the solve the problem. Now we know that because it's a projectile motion, because it's a question of projectile motion, we should know that, let's say, I'll start from here, that the time period formula is tu sine theta upon g. So you know the formula, substitute everything. So first of all, the initial velocity is 10 meter per second. So 2 times 10 into, what's the angle? Angle is taken as sine of 60. And then gravity, consider 10. Don't take 9.8. Always consider 10 for solving. Now, you can directly cancel them out to what is sine 60. Sine 60, I think all of you know, root 3 by 2. So it's just directly root 3 by 2, which is multiplication, will give you root 3. So that means you take root 3 seconds, first of all. And then for a vertical downward motion of the particle, B, from B to C, that means if you plot the graph, if you plot the projectile, you can find out the particle moving from B to C. To find that, you need again the same formula that we use over here. So in this case, we'll use S as our height, and we directly write half gt square, because in this case again initial velocity is 0. So we know that the gravity is 10, so we'll directly consider 10, and time is root 3 square, which is directly 5 into 3, which is 15 meter, this one. Alright, let's move to the next one. A body of mass 1 kg thrown with a velocity of 10 meters per second at an angle of 60 with the horizontal. Its momentum at the highest point is. So we want to find the momentum. Momentum is mass into velocity. But in this case, we have certain angle with the horizontal. That means there has to be an angle. And in this case, that angle is taken as cos theta, because we know that if you want to find the momentum, always take this as horizontal. The angle with theta around the horizontal is always taken as cos theta, with the vertical taken as sine theta. So in this case, momentum will be found by mv cos theta. Now substitute the values. Mass is 1, 10, and cos of 60. What is cos of 60? 1 by 2. That means 5 directly. So 5 kg per meter per second. Alright. Quickly, let's know, if a straight light of mass m is suspended from the end of a uniform rod of length L in a different possible patterns as shown in the figure, then now we need to know, okay, so which one is sturdier? Pattern A is sturdier, B, C, all will have the same sturdy. Okay, so cancel. Which one of them looks like it? So first of all, we need to know that how the tension of the body depends on this distance, as in the height. So first of all, because this mass is hanging, that means there is a tension between the string and the mass, that is weight of the body, is downward. Now they both should be in equilibrium, as well as the tension in the string should also be in equilibrium. Now that means to find the equilibrium, we can write this as mass into gravity, that is this one, into the distance, that means the height that we are taking, this, let's say the x height, at what height it is there, and then the tension in the string and at what height the string is hanged on. So if we find this equilibrium, that means we can rearrange this equation to write mgx upon y. Now, because we know the mass, do we know the mass? Okay, so we can find, okay, we don't need to find, we need to find which one is sturdier. That means your tension will depend on this x and this y. Okay, that means if tension has to be high, if the tension has to be, let's say, minimum value, that means your y should has the highest value. That means this y should be large if the tension has to be low. That means low tension, high distances. So this first pattern looks kind of easy, where there will be no tension or least amount of tension in the lamp. Okay. Next is a ball of mass 150 grams starts moving with an acceleration of 20 meters per second square, hit by a force which acts on it for 0.1 second. The impulsive force is, okay, so we need to find the impulse in this case. So it's an easy one, that is impulse. Directly say impulse is equal to force into time. Now because its force is not given, force is nothing but mass into acceleration into time. Mass is 150 gram, which is 0.15, into acceleration is 20 into 0.1 second. Multiply directly, so 20 into 15 will give you 3 into 0.1, which gives you 0.3. So 0.3 newtons second. 0.3 newtons second. I hope you get it. Directly multiply quickly. Right. Let's move on to the next question. Okay. Next is two springs A and B are identical, but A is harder than B. That means the spring constant of A is greater than the spring constant of B. Let work in A and work in B represents the work done when the springs are stretched through the same distances. Okay, that means let's say you have two springs. They are stretched with the same distances. Alright, let's call this A, let's call this B. Now the work in the A is considered WA prime, WB prime are the work done when these are stretched by equal forces. Then which of the following is true? Now because we know that the spring constant in A and spring constant in B, we know the relation that Ka is greater than Kb. That means we obviously know the formula that force is equal to Kx, right? So Ka and force B is equal to Kbx. Okay, so if you are moving them both with the same amount, that means we know which one will have, if forces are equal, if K is greater, right, that means we need to apply more force. In which cases, because Ka is greater, that means we need to apply more force to move with the same distances in case of this one. That means the more amount of force has to be put to move the same distance. Now, what we say is that we need to find out the relation between the works. That means to find the relation between the work, we know the relation that work depend on half kx square. So if we consider kx square, if we rewrite this half kx into x, let's say this is for A, body A, this one. That means we already know that which one has the most force. So if we compare in A, B and C, you can find that work done by the body A will be greater than work done by body B. Represent the work. So let WAWB represent the work done when the springs are stretched through the same distances. Now, this other work done when the stretched are by equal forces. So when they are stretched with the same distance, this one, we already know that WA will be greater than the WB. Now, when they are done with the same force, same amount of forces, that means this indicates, so we know that if we apply this formula, we can compare that WA and WB by using half KXA XA and similarly half KXP and XP. And remember, don't equate them. So we need to compare which one is greater. Because we already know which one is greater, we can easily say that this would be greater because Kx is large. So it comes out to be C. Now let's move on to the next one. Now, three identical spheres of mass m each are placed at the corners of an equilateral triangle of side 2m, side of 2 meters, taking one of the corners as the origin, the position vector of the center of mass. Alright, to find the center of mass, basically you draw the diagram. Imagine you have equilateral triangle which is kept on the origin. Okay, so if it is kept on the origin, we know that the summation of mass into this particular distance, x or y, whatever the distance is, divided by the total mass of the body will give you center of mass. Now, in this case, the only problem is that each of the mass is of same mass, so that means 2 kg. Mass is m, so consider capital M, M, and M. But the thing is that each side is of 2 meters. So this is 2 meter, but this height is of 2 meter. This is 2 meter. So then we need to find out what is the coordinate of this point. We know the coordinate of this point. Let me redraw it again on a different paper. Let's see. Because this is at the origin, consider 2 meter, 2 meter, 2 meter, and then because we need to find out the coordinate of this particular point. This particular point is 0, 0. This particular point is 2, 0. Now we don't know what is the point of this one, but to find the summation, okay, to find the summation values, we can write this as, because we know the formula, mass into this particular distance. Now in this case we can take all of them. We can find the y coordinate and we can find the x coordinate. So let's start with the x coordinate. Mass, first particle mass into position is 0, plus second particle mass into position of x position is 2, plus mass third position. Now we need to know the x coordinate of third one, which is nothing but just 1, because we know this point is 1, 0. So we got the position of this one divided by 3 times the mass. That gives you 0 cancel. This gives you 2m plus m, that is 3m upon 3m, which is just 1. So x coordinate we got as 1. Let's find out the y coordinate. Right. Now to find the y coordinate, again take mass, first particle. Let me take this diagram only. So first particle, the y coordinate is 0. Second coordinate, again mass into y coordinate is 0. Third mass into this y coordinate will be something like 2 sine of 60 degree. Now how do we get this 2 sine of 60 degree? I hope you know, if you take the triangle, because this angle is 60 degree, and you take 90 degree on this one, or let's look at this one. Look at this diagram. So this is your triangle, this is 60 degree. You can find the length of this one. If you find the length of this one, that is your y coordinate. So that comes out to be 2 sine 60, and when you calculate, this cancel, and you get only what is sine 60, which is root 3 by 2. So root 3 by 2, 3 by 2 into 2 upon 3m, which gives you 2 cancel, root 3 by 3, which you can again write, if you want to write, root 3 by 3, which is nothing but 1 upon root 3. Multiply root 3 on numerator and denominator, so you got x coordinate as 1 and y coordinate. So x comma y, I'll write this as 1 comma 1 upon root 3. So that means if I want to write this in equation ijk form, coordinate letters, so first one I is 1 and the second, so which option seems correct? So in terms of equation, it will be I plus j, or rather j, into root 3, 1 upon root 3, which is this answer. Alright, next. A wheel of moment of inertia 2.5 kg per meter square has an initial angular velocity of 40 radians per second. A constant torque of 10 Newton meter acts on the wheel. A time during which the wheel is accelerated to 60 rats per second is given by. Alright. Now the next question is a bit tricky, where you need to know how many things are known. So let me write this on the side, because then, okay. So simple trick is to just use your torque formula. I think torque formula. Let me write this as 10. Write this. Okay. For 10th one, torque is nothing but your moment of inertia into angular acceleration. So in this case, how do you know that what is the acceleration? Acceleration is given as 4 rad per second, and tau is given as 10. So you can find out. Acceleration is not given. So tau is moment of inertia is given as 2.5. Angular velocity of this is given. A torque of 10 Newton meter per second, that is 10, which is given. Alpha is not given. So this indicates alpha is how much? Which is 10 upon 2.5, which gives you, if you directly multiply, which will give you 4. Now, so we got alpha as 4. We want to find the time during which the wheel is accelerated to 60 radians per second. So it has initial angular velocity as 40. Now we want how much time, the time duration will take for the acceleration to be this much. Now we know from kinematic equation for circular motion that omega is equal to omega 0 plus alpha t. So that means the angular velocity I can take as 60. Initial was 40 plus alpha is given as 4. That means I can find out t. So let's just rearrange. 60 minus 40 is 20 equal 4t. So t is equal to 20 upon 4 is equal to 5, which says it takes 5 seconds. Okay. Next question. The correct option is, okay, ignore this question. The question is not complete, so you can ignore this part. Question number 12. The graph is drawn below. The applied force F and the strain for thin uniform wire. The wire behaves as a liquid in the part. Now, liquid at a part, that means if you have a wire and if you apply some strain, at certain point it will break, but before breaking it stretches. So these are the parts where it stretches. Now we want to find where it behaves as a liquid. Now for your information, the point at which it first starts to extend is the point B to C. This is the point where it behaves like a liquid. That means it can extend and then again come back to the same original shape. So BC is a line or the curve where it behaves as a liquid. Okay, next question. Now, so this question has 2 parts. Okay, so we'll see this question. Okay. Now, a vertical U-tube of uniform inner cross section contains mercury in both sides of its arms. A glycerine, which is density is given, column of length 10 cm, is introduced into the one of its arm. Oil of density this much is poured into the another arm until the upper surface of the oil and the glycerine are in the same horizontal level. Now find the length of the oil column. So we need to find out edge. Density of mercury is given. So density of each of the material is given. So if you have a glycerine on this side, oil on this side, we need to find out the length of the oil, this height. Now we know that because in U-tube this liquid is filled up, because this liquid is, we are considering which liquid? Glycerine, oil of the density this much poured into the water arm, mercury. Alright, so we have mercury over here. So if the mercury, it's written, sorry. So mercury is there. Now we consider that at this height, the amount of pressure and amount of pressure is equal. That means this is an equilibrium. Now, only thing that we need to find out is that what is the amount of pressure given by this one will be equal to the pressure given to this one. That means if you know the formula for the pressure, I hope you know. That means let's imagine that this pressure is PA and this pressure is PP, right? So PA should be equal to PP. We need to find this one. Now, by our formula, we know that the pressure is equal to rho GH. That means, let's say for A part, it will be rho GH, where we will consider this head height. The density of the glycerin, what's the density of the glycerin? It is given as 1.3. So 1.3, gravity will consider 10, and height is also considered as 10. Height is 10 centimeter, which this is for PA. Now PP, let's see. Now in this case, this height, because we know this is 10 centimeter, that means this height, this particular height is 10 minus h. Okay, now so that means this liquid is different, so we need to add up both of the pressure simultaneously. So first one will say that the height is height of, let's say for density of the oil, we don't know the height h, we know the gravity is 10, we know the density of the oil, which is given as, if you say the density of the oil of density 0.8, plus again the pressure by this particular part will be 10 minus h, again the gravity is 10, into density of the mercury. Density of the mercury is given as 13.6. Alright, so if we equate them, if we use this one over here, so this equal to this particular part, we can see that we can cancel 10, 10 and 10, which is basically gravity values. So we got on the left hand side 13, on the right hand side we got 4 into 8, h into 0.8, so 0.8 h plus 10, which is 13.6, so I can write 136 minus 13.6 h, which gives you 0.8 plus 13 minus 13, this one, so 136 minus, what is 13 minus 0.8, so will give you h, which is 13, so calculating h. Take 13 on that side. That's 13, 136 minus 13. So that'll give you 1, 2, 3, and divided by 12.8, which gives you something around 9.6. Now how do I get it? Because this, let's say, consider this is 1, 2, 3, and this is 1, 2, 8. This is almost like around 10. So if you don't know the values, it will be somewhere around. Now the confusion will be between this and this. Now we know that because this is a smaller value and this is a bigger value, we'll always get smaller number. Okay, so even if you don't know, if you don't want to cancel out numbers, you can still consider that this is somewhere around below 10. So below 10, but not too low, so the number can be directly taken as 9.6 even without calculating this particular part. Right, let's go to the next part. Okay, I hope you can see it. Okay. Next question is, choose the correct statement for a cricket ball that is spinning clockwise through the air. Now, when the ball is spinning through the air, let's imagine this diagram. When the ball is there, it is spinning in the clockwise direction. So the air around it, first of all, because it is going in a particular direction as well as spinning, so the air around it will be like this, which is also going in the same direction. Now what will happen is, because this ball is continuously spinning, all the lines which is around air is streamline. That's fine. So let's see the options. Streamline of air are symmetric around the ball. Okay, fine, it is not streamline but almost, but we cannot consider this one. We'll see later why. The velocity of air above the ball related to it is larger than that below the ball. Okay, we need to see that. The velocity of air above the ball related to it is smaller than the, okay, just opposite. There is a net upward force on the ball. Now, which one is more correct? Because in this case, the velocity of air above the ball related to it is larger than that below the ball. Okay, so in case this and this both are correct, let's see how. What happens is, because when the ball is spinning, now in this case it is spinning in the clockwise direction. This clockwise direction makes sure that all the air particle or the air goes down. It's like dragged below it. So most of the air is dragged below it, less amount of air is left on the upper side. That means the density over here and over here, so density at part 1 and 2 will be different. So amount of air will be different. Because of this difference in the air density, there will be change in the pressure, and because of this pressure you will have high pressure from this side compared to this side. So because of this high pressure, so we also know that more pressure, more is the velocity. So what happens is that the air velocity of air above the ball related to it is larger than that below the ball, because most of the air wants to go down because there is a low pressure. Now the point is that there is a net upward force on the ball, because the pressure difference is created, as well as velocity is different, because of which you will have net upward force which will push the ball up. So option B, S2 and S4. Now, which of this prism is used to see infrared spectrum of light? Okay, to see the infrared spectrum, most of this options, flint glass, nickel, crown, all of this, most of the glasses are normal glasses which is used only for visible light. Now only thing that this infrared, this one is refracted, because all the other glasses absorbs the infrared radiation, because all those infrared are of very low frequencies, whereas rock salt transmit those radiation and goes out. So we can see the spectrum of the infrared using the rock salt. Alright, next question. Which of the following statement is true? Alright, so internal energy of a gas depends only on the state of the gas. Okay, seems correct, because we already know that whatever the state of the gas is, that means state as in the velocity, the volume, the pressure inside the gases, the temperature of the gases, the kinetic energy of each of the molecule. All of this should have exact same thing. So when we say internal energy says that the total energy inside a particular gas, that is all the kinetic energy and everything of the molecule. So internal energy of the gas depends only on the state of the gas. Yes. In an isothermal process, change in internal energy is maximum. Isothermal as in the temperature remains constant, it does not change. So in this case, change in the internal energy is maximum Highly unlikely. It doesn't depend on that, because if the system is isolated, it might change. Area under the pressure volume graph equals heat supplied in any process. Alright, this is also not correct, because no, it doesn't depend on that. Work done in state dependent but not path dependent. Alright, work done is state dependent but not path dependent. Okay, it's not path dependent, but it is also not state independent. So no, only true option is part A, where the total energy, the internal energy, depends only on the state of the system. Because if you take a system from one form to another, that is one state to another system, it's the only thing that changes, because we know that the formula is Q minus W. Because we know this formula, that means the internal energy does not change even if you change the amount of work, amount of pressure, and volume, and all those states. So it remains constant. Okay, next is, alright. Now a thermodynamic system is taken from state A to B along this ACB, and then they brought back to A along this PDA path, as shown in the PV diagram. The net work done during the complete cycle is given by the area. Now we already know, because when we first use the graph, first the point is going from A to point B using this particular curve. Now if it is going through this particular curve, that means the total work done is given by this area, right? But in the next term, it is coming back towards it. Now that means the work done in this case will be the area under this curve, this one. Now that means this area minus this area, because it is coming back to the same point, that means the total work done, that is the net work done, will be the area given by this particular region, which is basically this subtracted this lower part, which will give you this one. So that means this total area should be A, C, B, D, A. That is given by this one. All right. Next question is, the latent heat of vaporization of water is 2240 joules if the work done in the process of vaporization of 1 gram is 168 joules, then increase in the internal energy is. Okay. So let's see. So it is simple again. We just saw the formula that du is equal to dq minus dw. Now in this case, the heat amount, which is vaporization of water, latent heat of vaporization is 2240 of joules of energy, and if the work done in the process of vaporization of 1 gram is 168, that means work done is 168 joules of energy, then increase in the internal energy, subtract this, directly get 2072 joules, which is option. Alright, let's move on to the next question. Particle of amplitude A is executing a simple harmonic motion. When the potential energy of the particle is half of its maximum potential energy, then displacement from its equilibrium position is given by any of the options. Okay, now the simplest thing is to know that your potential energy is given by half m omega square x square, right? So in this case we know that it is oscillating. Now in this case, particle is executing simple harmonic motion, given by this formula. The potential energy in the particle is this much. Now half of it, so energy of the particle is half of its maximum potential energy, then the displacement from its equilibrium position is, that means the next time the potential energy for the maximum, let's consider that as half m omega square. Let's say the maximum amplitude can be a, the minimum can be x, right? Now, so given position, we just need to, we know that your potential energy is nothing but the total energy is half value, right? So that means just substitute all those values. So half m omega square x square is equal to this half of half m omega square a square. So cancel out each of them, m omega cancel out. You get x square is equal to half a square, which is nothing but x equal 1 upon root 2 a, which is a by root 2, a by root 2. So yeah, so the displacement that the particle has to do to have the half of the maximum energy, the displacement is given by maximum amplitude divided by root 2. Okay, next one is the motion which is not simple harmonic is. Now in this case, why? First of all, simple harmonic which oscillate and continuously repeat itself. So a vertical oscillation of spring. Okay, so spring is constantly oscillating. So yes, that is example of that. Okay, we'll not take it. Motion of simple pendulum is also a simple harmonic example. Motion of planet around the sun. Okay, this is not an option. Why? Oscillation of liquid column in a U-tube is again coming to and fro motion is there. Now why this motion of a planet around the sun is not considered as simple harmonic? Because it doesn't do, first of all, to and fro motion. The periodic motion, the time is constant, but the period, or rather say the orbit of the planet is not as simple as it looks like. It's not just in the orbit and it is revolving around it. It's also moving like this, like this. So it's not completely simple harmonic motion. So yeah, this is not the option. So take it. Next is okay. In this case, we need to find out the number of beats. Two waves are represented by these two different equations. We need to find out the beat frequency and the ratio of maximum to minimum intensity. Now we know that the beat frequency can be found when we know the two frequencies. That means in this case we need to find the frequency of this equation and frequency of this equation. So how do we find the frequency? First of all, we know the frequency is given by omega is equal to 2 pi f. Correct? So we start with finding omega 2 is equal to 2 pi f2. Now in this case, let's find out what is omega 1 and omega 2. Now in this case, omega, because if you look at the equation, this is of the form, this equation is of the form of y is equal to a sine of omega t. So in this case, what is omega is your 404 pi. Correct? So 404 pi is your omega. So we know 404 pi is your omega. So if we just rearrange this equation, we get f is equal to 404 pi upon 2 pi, which cancels out and gives you 202 hertz. Similarly, this is frequency 1. So in this case, next equation is 400. So this is 400 pi is equal to pi f2. So f2 is equal 400 pi upon 2 pi, which gives you 200 hertz. So we found the frequency of both of them, 202. So now if we found the frequencies, now the easiest way to find the the beat frequency is just to subtract them. That means f2 minus f1, which is nothing but 202 minus 200, 2 hertz. Alright, so we found the beat frequency. So if you look at the options, B and C has two frequencies, 2 hertz as a frequencies. Alright, so So after finding the beat frequency, to find the minimum and maximum intensity, just use the formula maximum intensity upon minimum intensity, which is given by this particular formula. And we know that the amplitude of both the waves are, for first wave it is 4, which is A, and this one is 3. So 4 plus 3 upon 4 minus 3, which gives you 49:1. So the correct option comes out to be 49:1. Option B is correct. Okay, let's move on to the next one. 22nd. Let V be the electric potential at a given point, then the electric field Ex along the x direction at that point is given by. Now in this case, always remember that the electric field intensity is always your dV upon dx. It's always the potential gradient and shows the negative sign. So it's the potential gradient, which is this option. Okay, so you just need to know the formula. Now next is the number of ways one can arrange 3 identical capacitors to obtain distinct effective capacitance is. Okay, I'm cancelling this out. Or rather we can find out this one. But mostly if you want to find out the actual answer to this question, it's kind of simple to find out that there is only 4 options that we can arrange the 3 identical capacitors so that we can find the effective capacitance. There's a minimum arrangement for 3 identical capacitors, because we can write this 1 capacitor, 2nd capacitor, 3rd capacitor in a different arrangement to find out the effective capacitance. So there are, obviously, because we know this is 3, how many ways can we arrange them? This is a mathematical question. Ignore it. Alright. Next is C, V and U and Q are capacitance, potential difference, potential energy, energy and energy stored, and the charge of parallel plate capacitor respectively. The quantities that increase when the dielectric slab is introduced between the plates without connecting the batteries are. Okay, so in this case, which quantity will change? So quantities that increase when the dielectric slab, that means you're introducing a new medium in between the capacitors, which quantity will change. Now we know that the capacity that when you introduce a new capacitor dielectric material medium, the material medium, we know that capacitance will always depend on the dielectric constant, right? So it depends on whatever the dielectric constant that we are using. It will just change. That means the new capacitance will be different than the previous one, obviously. Similarly, when you talk about the inner charge of a parallel plate capacitor, will also change because the new material will introduce more charges. It might introduce new charges, so your capacity will increase. Similarly, but remember, the potential should remain constant, as well as the energy should remain constant. So the only thing that changes is Q. And also let's talk about the energy. The energy stored in the system will also change. So if all of them is changing, so we can say which one will increase. Okay, we need to find the quantities that increase when the dielectric slab is introduced between them. That means U and Q will increase in the amount. Whereas the capacitance, even if this formula is introduced, the capacitance of the capacitor will remain constant because V is not changing. So only thing that increases is your energy stored in the system and the total charge of the parallel plate capacitors. So in this case, your answer would be U and Q. Next question. I'll keep it side. Okay. Now, the next question says, you can see the question. A battery consists of a variable number of n identical cells, now each having an internal resistance R connected in series. The terminal of the battery is short-circuited. A graph of current versus the number of cells will be shown in the figure. Now, If you look at the graph, now the question says that you're connecting number of cells in a series, identical cells each having internal resistance R. So even if they have internal resistances, that means the resistances will keep on adding because they're connected in series, as well as because there are cells where they're connected in series, that means the total potential will also keep on adding up. But the terminal of the battery is short-circuited. The graph of the current versus the number of cells. So if you increase, let's say if I increase the number of cells, one cell, second cell, third cell, and if I keep on adding those cells with each having internal resistance R, what will happen? Am I short-circuiting the circuit? What will happen? Which graph is more suitable? In this case, you can see that even if you increase the battery, if we talk about the current, the amount of current in the circuit, because it is short-circuited, it should remain constant. It should not change even if I increase the number of batteries. So in this case, the only graph that shows the constant current is this one. So we'll consider this as an option. Whereas this option is for the ohmic resistance and all those things. Whereas in this case, no, it cannot follow. As you increase the number of batteries, the current does not drop. It keeps on adding up. So correct option is C. Now, so we are skipping this question because there is something wrong with this question. Let's move on to the next question. Now, in a circuit, the galvanometer G shows a zero deflection. If the batteries A and B have the negligible internal resistance, the value of resistor R will be. So basically we need to find out this R. So that means it says that the galvanometer shows no deflection. That means there is no current that is flowing, which also means that the potential across this is equal to the potential across this. That means the amount of voltage passing through this resistor is 2 volts. Alright, so if you know that, that means first of all, we can consider this, that they are connected in a series. That means I can be written as V by R, where mean potential is 12, and the total resistance can be considered as 500 plus this R. Okay, we don't know what this current is, but we also know that the voltage passing through this is 2 volts, and that means we can find out, we can apply the V is equal to IR formula over this one, whereas we know that the potential is 2, so that means we can write this 2, and we don't know the current, but we can write the current as 12 upon 500 plus R, as well as this capital R, like this. Now, when we simplify this one, let's simplify this case. So 12R plus 500 plus R. Let's rearrange this. It gives you 1000 plus 2R equal 12R, which gives you 1000 is equal 10R, which gives you R is equal to 100 ohm. So 100 ohm. Okay. Next is, in the given figure, the electron enters into the magnetic field. It deflects in which direction? Now, if the electron is entering into the magnetic field because it is moving in this direction, you can use the Fleming's left-hand rule to find out in which direction the electron will move. The deflection should happen. So, if you use the Fleming's left-hand rule, the Fleming's left-hand rule says that if your thumb will indicate the force direction, if this is your magnetic field direction, now in this case we can see cross, that means the fields are going into the page, and I shows the direction of the current. Alright, so that means the electron is moving in that direction. So if we consider the electron flow as this direction, this direction, as an electron flow is always considered from negative or from positive to negative, but the current is always considered from positive to negative. That means your current is flowing in this direction. Imagine current is flowing in this direction, your magnetic field is going in the page, into the page. That means the amount of force will be downward. That means in the negative y direction. Okay. Now, next question is, a current carrying small loop behaves like a small magnet. If AB its area and M its magnetic moment, the current in the loop will be. Okay. So we already know that magnetic moment is given by current into area. So if you know this formula, so we need to find the current. That means current is equal to magnetic moment upon area. So for 29 it's 8. Next is okay. Next question is a connected question. So let's see what this is. It's again direct formula based question, if you can see. It says the Earth's magnetic induction at a certain point is given by this value. This is to be annulled by the magnetic induction at the center of circular conducting loop of radius 15 centimeter. The required current in the loop is required current in the loop. Okay, now so it's directly, because if we are talking about circular loop, we know that the magnetic field provided by the circular loop is given by mu 0 I upon 2r. So we know each of the values. We know that the magnetic field is 7 into 10 to the power minus 5. We know this 4 pi upon mu 0, but okay, 4 pi into 10 to the power minus 7 can be taken as mu 0 value. You need to remember this value. Current is not known. 2 into the radius. What's the radius? Radius is 7. No. Annulled by this one. Loop of radius 15 centimeter. So 15 10 to the power minus. So the radius comes out to be 10 to the power minus 2. If you calculate this one, now easy calculation, but let the power as it is, 10 to the power minus 2 minus 7 give you 10 to the power minus 5. Okay, I is not there. Now 10 to the power minus 5 and minus 5 cancel, so you all so calculating this one, we'll get 2i upon 4 pi, which gives you upon pi. So after calculation, this is basically division by 3.14, which will give you somewhere around 5 points, because this is, let's say consider this as 22 points by 7, it's 52. So 52.22 into 7, that gives you, let's say 26 upon 11 into 7, which you can calculate somewhere around 11 to 22.40 33.706 into 7. Oh, did I miss something? 4 pi 10 to the minus 7. Oh, sorry. There's a slight difference. Circular conducting loop of radius 15 centimeter. Oh, so the question actually has 5 instead of 15. So this is 5. So this will be 10. And because this is 10, so this will be 70. And cancel it, okay. So I equals 70 upon 4 pi. which will give you 70 upon 4 into 22 upon 7, 70 into 7 upon 88, which you cancel out, and you can find out that it comes out to be somewhere around, because this will give you this, and if you want to cancel out, 245 and 44. So if you see which one would be the right answer, the more accurate answer comes out to be somewhere around 5 point something, right? So option P, 5.6, which is easy. Okay, next question is again a bit of formula based, which is based on your EMI chapter. A current I is equal to 10. This one is passed in the first coil, which induces a maximum EMF of 5 pi V in a second coil. Now the mutual induction between the coil is, so I think you know that the mutual induction, to find this induction value, you know the formula. Okay, I will write 31st question over here. You know the formula that the EMF induced is given by negative of L di upon dt. Now in this case, first of all, because I is given, so first we'll find di upon dt, which is differentiating this equation. So after differentiating, you'll get, because there's a sign of 100 by t, so when you differentiate, you'll get 10 into 100 pi cos of 100 pi t. Alright, so you got this one. Now because we know that the EMF is 5 pi V, that means we need to find the mutual induction, which is L is equal to E upon di upon dt. Now, so if you directly calculate, because this is 5 pi V upon, this gives you 1000 pi, which is 10 to the power 3 pi cos of 100 pi t. Alright, now how will you find the value of this one? Because cos of 100 pi t, now because this cos of n number of pi, because this is an even number, you will get this as equal to 1. So this will be 5 pi upon 10 to the power 3 pi into 1, which is nothing but 5 into 10 to the power minus 3, 10 to the power minus 3, because this is calculated in Henry, this is nothing but 5 millihenry. So the correct option is this one. Next is, a pure inductor of 25 millihenry is connected to a source of 220 volts. Given the frequency of the source as 50 Hz, the RMS current in the circuit is. So first of all, to find the RMS current, first we need to find out what is the inductive reactance in the circuit, which is, okay, I'll write it down. So inductive reactance L is given by 2 pi V L, where V is your frequency, L is the inductance in the circuit. So let's substitute all the values, 2 into pi into what is given as, the frequency is given as 50 Hz and inductance is given as 25 milli, that is minus 3. So you can find XL, just multiply 50 into 200, 100 into 10 to the power minus 1, so 25 pi 10 to the power minus 1. You can further simplify this question, but let's keep it as it is. And now to find out what is the current in the circuit, because we want to find out what is the current, RMS current in the circuit, we know that the RMS current, IRMS, is given by VRMS upon XL. Now in this case, VRMS, that is the voltage in the circuit, is 220 divided by this 25 pi 10 to the power minus 1. Now easy calculation, let's see how much calculation can we do. So let's do with 5 pi, which is goes up, gives you one more 0. So we can directly calculate. (88 upon pi) will be the answer. Now, because we need to find out the exact value, so what will be the value? 88 upon 22 by... Okay, so after calculation, we got 28, which is in amperes. That means this has 28 amperes of current in the circuit. Right, so resistance of the silicon will increase and that of the platinum will decrease because of the negative temperature resistance and positive temperature coefficient of resistance. Alright, next is through which of the mode of propagation the radio waves can be sent from one place to another. Remember, radio waves are the waves which are easier to send in any kind of propagation. So it can be sent from ground, sky or space. That means all of them. Okay, last question is the velocity of all radio waves in free space is this much. The frequency of the radio is the frequency of the wavelength 150 meter. So it's an easy one. We know that the velocity is equal to frequency into lambda, right?